All right, so section 13.4, increasing and decreasing functions. So this would be something where you might be doing this on a part of the test that is a non-calculator part, just because if I ask you if something is increasing, decreasing, you can just graph it. So if you are tempted and thinking, why don't I just use the calculator to graph this, that would be why. You might have some of it while you have a graphing calculator, but some of it would be without. Also, this section is not on your quiz, so this will obviously be on your test, but the quiz will just be over sections 1 through 3. All right, so first of all, looking at a graph from left to right, which is always how you evaluate a graph, a function would be increasing if the function has a positive slope. It would be decreasing when the function has a negative slope. So looking at the picture here on this page, the blue line is increasing, the red line is decreasing. Again, looking at it from left to right. Now, first of all, just a little bit of information about notation. Whenever I talk about things being increasing or decreasing, I will normally use, what's the word I'm looking for here? I use parentheses, that's the word I'm looking for, an open interval as opposed to a closed interval. So on the picture that we have going on here, we're increasing from the start of the graph, which starts at -5, and we're increasing until we get to 2. Now, when you give these intervals of increasing and decreasing, you're giving it as intervals of x's. It's like for how long. I don't care what I'm increasing to, I just want to know when do I stop increasing. So on my graph here, I stop increasing at 2. Now, depending on the book, and apparently your textbook is in this kind of camp here, they will use a closed bracket on that, which means that 2 is included. Well, personally, I look at it as it's not increasing at 2, it's not really doing anything, like that's where it stops increasing. So it's increasing all the way up until you get to 2, but at 2 it's not really doing anything. So I would use a parenthesis there. Apparently it doesn't really matter. And that was something that I didn't realize till I started researching why does our book have brackets there. The only thing that is not negotiable, okay, so in this case this graph is decreasing as you continue to go to the right. So it's decreasing at 5, 6, 7, 8, all the way to positive infinity. Well, you can't get to positive infinity. So infinity is always, always, always an open interval. So when you're talking about that interval of decreasing, you could say it's decreasing from 2 to infinity, or you could say it's decreasing from 2 to infinity. But notice the only wiggle room there is on what you do with the 2. Are you saying that it's decreasing right past 2? Are you saying it's decreasing at 2, which would be the bracket? But you cannot say that you stop decreasing at infinity because you can't get there. So essentially, never use a bracket with infinity. Otherwise, when you're doing intervals, it doesn't really matter if you use a bracket or a parenthesis otherwise. Okay? All right, so looking at a graph here, if the derivative f prime of x is greater than 0, which means positive, for an interval, then it's increasing on that interval. And if it is negative, it's decreasing on that interval. Now, remember that if you have a positive slope, that is the same thing as having a positive derivative, because the derivative is where the slope comes from. Same thing on the flip side. Okay. And then finally here, a stationary point, that's where your derivative is equal to 0. That would be on the graph someplace where you have a minimum or a maximum point. And that's because you're not actually increasing or decreasing at that spot. So for example, on my picture up here, the yellow arrow, that would be a stationary point. My derivative is equal to 0 there because the slope of the tangent is 0 there. It's not really increasing or decreasing at all at that point. So stationary, not moving. So first couple questions here. You've got several questions in your homework where you're just looking at a graph. So write the intervals on which the graph is increasing and decreasing. Now, I need to have some arrows on here. Hold on, let me make sure I'm drawing it the same way I have it on my paper. Yeah, I want arrows on all of these here. Okay, so we are going to be increasing on the first graph here from 0 to infinity. Remember, you can put a bracket on the 0 if you want, but you have to put a parenthesis on the infinity. We're decreasing from negative infinity to 0. Okay. The infinity isn't supposed to be kind of shifting up like that. That's just the fact that sometimes I have issues drawing infinity. The next one, this would be increasing the entire time. So from negative infinity to infinity. The graph is, the whole time going up kind of thing. Okay. The last one, we are increasing from negative infinity until I get to 0. Okay, that would represent this right here. Then we start going down. We're going down from 0 until I get to 2. Actually, let's switch colors for that. Okay, so from 0 to 2. And then we're going up again from 2 to infinity. Okay. Now remember, these are intervals of x's. In some cases, like this one, for example, when you're talking about the decreasing, you might be tempted to say that you're decreasing from infinity to 0 because you're coming down from way up in the air, which would be infinity, but it's the x value. So for that graph, as far as I can go left, which would be negative infinity, I'm going down, 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 down until I get to 0. Okay. All right, next, let's use the derivative to find the intervals on which f is increasing or decreasing. Now, let me tell you a secret if I haven't told you this already. You will be allowed to use a graphing calculator for the entire exam on the IB exam, not necessarily our exam in here. So that being said, what do I need to do what I'm getting ready to do here? Because I can just graph it. Well, for one, graphing's not always going to give you an exact answer. And two, if it says use the derivative to find the intervals, but you just graph it, then you haven't used the derivatives to find the interval. So it is still something you need to be able to do regardless. So first thing I need to do is find the derivative. Obviously it says to use the derivative. So this one's pretty easy. F prime of x would be equal to negative 6x minus 18. Now, essentially, what I'm looking for here is I'm looking for that stationary point because we're going to be increasing and decreasing on either side of a stationary point. And the stationary point is when the derivative is equal to 0. So take the derivative, set it equal to 0, okay, and then solve. So 18, negative 6x, x is negative 3. Okay. Now, I'm going to draw a little picture here. Okay, and I'm going to put negative 3 here in the middle of a number line. So what I'm going to do is I'm going to plug a number in on either side of negative 3. So 0 is a good, easy number to plug in. And then we'll do negative 6 just to keep the numbers equally spaced, but they don't have to be. Okay. Now I'm going to plug these numbers into the derivative. So here is the derivative. I'm going to do f prime of negative 6. So negative 6 times negative 6 minus 18 gives me positive 18. So I'm going to write a plus right here. What that means is that actually every number to the left of negative 3, so negative 4, negative 5, negative 6, negative 1,000, is going to give me a positive answer. What's happening is the graph is increasing positive slope the entire time. There's a positive slope. It's increasing the entire time. Now, f prime of 0, obviously that's pretty easy to plug in. That ends up giving me a negative 18. Now, they're not always going to be the same but opposites. That's just the way this one worked out. So that side of the negative 3 is going to be negative. Every number that I plug in to the left of negative 3 is going to give me a negative number. That means that all of those slopes are negative. So what's happening is where it's positive, the graph, like I said, is increasing, positive slope. Where the graph is negative, decreasing, negative slope. So use the derivative to find the intervals. The increasing interval, we'll do that one first, is going to go from negative infinity to negative 3. Negative 3 was my stationary point. Actually, I'm going to put that in blue just so you know that was the point that we got there. Okay. My decreasing interval, that's going to be starting at negative 3, going to 0. Nope, not going to 0. 0 was the number we plugged in, but it's going to infinity. As far as I go to the right, that graph's going to continue to go up. Now, you could graph that and check it. This is a parabola. It's a parabola that goes down. So if you think about that, that makes sense. Your graph's going to be increasing on the left and then decreasing on the right, something like this, okay? So the -3 is happening right there. We're increasing on the left side, and we're decreasing on the right side. Okay. Right? Same process. So the next one, we find the derivative. So f prime of x is equal to 2. Well, I would set that equal to 0, except I can't. So what do you do there? Well, how we find out when it's increasing and decreasing is we look at the sign of the number. In this case, the derivative is always 2, so it's always positive, which means it's increasing the entire time. So in this case, since 2 is positive, it is increasing the whole time. Now think about that. You know how to graph that. 2x minus 7, there's a positive slope. So you're going up the entire time. So we're increasing from negative infinity to infinity. And essentially a line, not a horizontal line and not a vertical line, but a regular line, a diagonal line, is always going to be either increasing or decreasing the entire time. Okay. All right, last one of these, f prime of x is equal to 6x squared minus 6x minus 12. Okay, set that equal to 0. Okay. Now, you could solve this in a variety of ways. You can do the quadratic formula. You can use your equation solver and your calculator, but we can factor this. But first, let's divide everything by 6. Now, if you're dividing everything by just a number, you can totally just get rid of that number. If you're dividing it by a letter, you can't do that. Now, if you're unsure, let's just go ahead and leave the 6. And then we factor one more time. Well, when you set those 3 things equal to 0, you can't set 6 equal to 0. That doesn't make any sense. So you get 2 answers. You get 2 and you get -1. So that's why it was okay just to divide that 6 out completely. If I was dividing an x out, that would definitely have to stay because it would get set equal to 0. Okay. All right, so in this case, we have 2 numbers here. We have -1 and we have 2. So I need to plug in 3 numbers this time. So I'm going to plug in 3 right here. I'm going to plug in -2 right here. And I'm out of numbers to plug in here, colors, different colors there. So I'm going to use a 0 right there. Okay. Tell you what, I'm going to underline these numbers so I know which numbers it is that I'm plugging in here. Okay. All right. So now back into the derivative. All right. So I'm not going to write down where I've plugged all these numbers in, but we're going to do f prime of -2. Now, when you plug it into the original, okay, so we're plugging it into there. That's going to give me a positive 24. So I'm going to put a plus right there. Okay. One thing that I do sometimes too is I kind of make these barriers a little bit bigger, okay, so I can see my intervals. All right, next I'm going to do f of 0. That's going to give me -12. So put a negative right here. And then finally, f of 3. Oh, sorry, these are prime. F prime of 3, that gives me a 24. Now, that's a coincidence that it gave me the same thing, but that's a positive. So we are increasing from negative infinity to -1. Also from 2 to infinity. Well, let me put that one in red so we know where we got that one from. That's the other side here. 2 to infinity. And then we are decreasing from -1 to 2. Now, be careful when you give these intervals. Don't use the 3 and the 0 and the -2 in your interval. That was just me testing the interval. The intervals are going to have to do with those stationary points, the -1, the 2, and in the case of the increasing intervals, infinities, because we don't stop increasing in those. Okay. All right. So just a couple questions here from a graph. We've already kind of done some of this already, but some of this is about the way it's worded. So in this picture right here, where would you say that f of x is increasing? Well, remember that's a positive slope. So we're looking at a graph that's going up as you go from left to right. So we're going to be increasing from here to here. Y values, that's going to be from 1 to 3. And then we're increasing from, let's just say 4 to infinity. Now, where would it be increasing the most? It's going to be where it's the steepest. So looking at the graph, where does it seem like it's going up the fastest? That's going to be the last one there. All right, where is f of x decreasing? All right, well, we're decreasing at the very beginning. We're going down. So that's from negative infinity to 1. Okay, so we're going down till we get to there. Then we're going up. Then we're going down from here to here. So we'll say that's from 3 to 4. Okay, where is it decreasing the most? Again, that's going to be where it's the steepest. It's going down the fastest. That's the first interval. Now, where is the derivative equal to 0? That's going to be equal to 0 where you have a slope of 0. So that's going to be here, and that's going to be here, and that's going to be here. So x equals 1, 3, and 4. Where does the graph have tangent lines that have a positive slope? Well, that's the same as part A. Positive slope means that the graph is increasing, so that's going to be 1, 3, 4, infinity. I want to go back up on this last one here and say that the slope was 0. That's how we came up. That's what that meant. Where does the graph have tangent lines with negative slopes? Same thing. This is going to be the, or same kind of thing. This is the same as part B. So a negative slope means a negative, or means that it's decreasing. So negative infinity to 1, 3 to 4. And where does the graph have a horizontal tangent line? Well, remember the tangent lines have to do with the slope. If you have a horizontal line, you have a slope of 0. So this is the same as part C. So x equals 1, 3, and 4. Okay. Now, I know that seemed kind of silly to ask you the same question twice, but that's the way you might see that in your homework, where they ask you the same question, but they ask it to you in a different way, so it seems like something new, and really it's not. Okay, next. Sketch a possible curve given the information below, then state the value or values of x for which your function would have a horizontal derivative. Okay, so this is totally a sketch. The graph is going down from negative infinity to negative 3, then it goes up from negative 3 to 0, decreasing, so on and so forth, and then f of 0 is 1.5. Okay, so let's actually start there. F of 0 is 1.5. So that means that I have the point 0, 1.5 on my graph. So over 0, up 1.5, something like that. All right, now what I'm going to do is I'm going to mark these other points here. There's negative 3, of course here's 0, here's 2, and we can't mark infinity. So what's happening is the graph is going to go down until I get to an x value of 2, and then it's going to go up until I get to 0, and then it's going to go down until I get to 2, and then it's going to go up from there. How far down are you going? It doesn't say. I'm going to stop going down at negative 3. So, and negative 3 is that first tick mark that I labeled. So we could say that we're doing something like this. I didn't really mean for that to have a bend in it, but we're going down, down, down. I stop going down when I get to negative 3. Now, if your graph doesn't go down as far, that's fine. If your graph is on the other side of the y-axis, or on the other side of the x-axis, that's fine too. The next one, I'm going to increase from negative 3 to 0. Now, this one, I have a stopping point here. We're going to go from negative 3 to 0. That's a point that they told me was on the graph, so I kind of have to go there. Otherwise, if they hadn't told me that f of 0 was 1.5, I could have gone higher, I could have gone lower, because they didn't tell me. Okay. Now we're decreasing again from 0 to 2, so that's the next point there. Now, how far do I go? I don't know. Again, it doesn't really tell me. I'm just going to kind of dip down a little bit there. And then we are increasing again. So now from 2 to infinity, I'm going to go up. So kind of a W looking shape here. Now, my suggestion would be, if you are asked to draw a sketch like this, to look at your sketch again and see, okay, so when is my graph going to be decreasing? It's decreasing from as far as I go left until I get to -3. Check. Okay, we're increasing from -3 until I get to 0. Check. We're decreasing from 0 to 2. Check. And we're increasing from 2 to infinity. And hey, f of 0 is 1.5 is on my graph. Okay. So again, how low the graph go is just a guess. Yours might go lower than mine. Yours might go higher than mine. It's also a guess where it's crossing the x-axis. If you look at my notes that are on the website, the graph looks different than this one does. It doesn't tell me where it's going to cross. That's why it says a possible curve. If they hadn't told me again that this point was on the graph, I could have made my graph go higher, but they did. So, now the last part of the question was state the values of x for which your function has a horizontal derivative. That's going to be where the slope is 0. That's going to be where we have horizontal tangent lines. So that's going to be at x equals -3, x equals 0, x equals 2. Now, we'll talk more about this in the next section, but essentially these are your minimums and maximums, your peaks and valleys, so as we go along there. Okay. All right, last one. This is kind of a random question that doesn't necessarily have anything to do with increasing and decreasing, but it's a really good question that you could definitely see again. So if you have a function of the form y equals ax squared plus 5x minus 4, and f of -3 is equal to -1, solve for a. Okay, so if f of -3 is equal to -1, that means that -3, -1 is on that equation up there. So let's plug that in, see if we can figure out what a would be. So that's going to be -1 would be equal to a -3 squared plus 5 times -3 minus 4. Okay, so that's going to be -3 is equal to 9a minus 15 minus 4. Okay, so -1 is equal to 9a minus 19. 20 would be equal to 9a. Oh, no, hold on, something went wrong here. Oh, because on my paper I changed the 9 to a 2 for some reason, which would not happen. So we divide, it's just not, a is just not going to be a nice number. So 20 divided by 9 would be a, and it doesn't simplify from there. So that's it. 29ths would be my a value. All right, I stopped the recording here just for a minute because I wanted to double check why I had given you this question, because it does seem kind of silly. So this is related to question number 8, which you do have in your homework. It is different. They want you to draw a picture, and they want you to find out what's going to make the derivative equal to 0. And then they give you some kind of a similar question here where they ask you to solve for the letter A. So how this pertains to that, even though it's really actually a pretty different question, is that if you know a point that is on a function, you can use it to solve for letters that you don't know. So in the case of the question in your book for number 8, there is a derivative that you're going to be finding that has a letter in it that you don't know. But if you know a point that is on that derivative, which you do within the process of that question, you can solve for that. So look at the solutions. Let me know if you're stuck on that, if you can't quite figure out what I'm getting at. But again, this one is similar to example 8, well, we'll say homework number 8 in your book, and more specifically towards the end of that question. So, okay. All right, that's it. We'll do some more with the increasing and decreasing stuff in the next lesson.